The most important thing about the conduit fill, let me go here, and if I can get my signature here out, view. Okay, Zoom sign in. I don't want to do that. Okay. I want you to focus on this particular topic here. Let me note 200. Let's take 150. For conduit fill, guys, every conduit approved by the NEC code book has an article in chapter 3. And in every article, you're going to find a section. The section is always ends up with 0.22. Why am I interested in this section? So this is 358. This is EMT conduit, the single most important conduit that I use in the industry. In commercial, residential, we can use it anywhere else. I would say 90% of what you're going to be using is EMT conduit. You're looking at it right there. Can you guys see that? So how many conductors you can fill in this conduit? I picked this particular one because it's so important. Each conduit, respected, approved in the NEC code book, is going to have something similar. And can you guys see that little dot 22? If you go to dot 22, it will tell you the number of conductors in this particular conduit. So the number of conductors shall not exceed. Can you guys see the shall not exceed? That permitted by the percentage fill in chapter 1 in table 1, chapter 9. Cable shall be permitted to be installed where such use is not prohibited. And the number of cables shall not exceed. Can you guys, I can't emphasize this one. Also the cables shall not exceed table 1, chapter 9. Probably this is the most, I don't know if you guys emphasized when you were with our electrical construction, how emphasized that you can put cables in a conduit and you can put conductors in a conduit. What's the difference? Conductors are single conductor cable. Cables are multi-conductor cable. So MC cable, an M cable, I can stick it right into an EMT conduit. Why the heck would you do something like this? Why would you put a cable, an NM cable Romex into an EMT conduit? Physical protection, if you need to protect it from physical damage. Now, how many NM cables can I put in a 3/4 of an inch EMT conduit? How do you do the calculation? Table 1, chapter 9. Can I guess get you to understand? So this applies for M cable, AC cable, MC cable, and multiple, any other cable. That particular one here. This one applies to THHM conductors, THW, THHW, etc. Conductors. Can you guys emphasize the word conductor? A single conductor cable. So that baby here will be one conductor with an installation THHN. This baby here will be 1, 2, 3, 4, an MC cable, for example, with an installation THHN. You see the difference between multi-conductor cable and single conductor cable? Both of them, when we do conduit fill for cables or conductors, we have to go to table 1, chapter 9. Can I have thumbs up, Chad? We fully understand these tables are used for cables and conductors, especially cables. A lot of people forget the word cable. Okay, so that's basically it in terms of any other. I picked this one, guys, because probably it's the most important one. But by any means, any other conduits like rigid, EMT, PVC have the same number, except it's going to have the same dot 22, except the article is going to be different. Did you guys hear me? The article is going to be different, but you're going to see, for example, I always say star dot 22. If every conduit approved in any single book is going to start with 3-digit name of that conduit article plus the dot 22 that applies to how many single conductor or multi-conductor cables you can stick in this conduit. Check for this. Everybody approved that? PVC, rigid, EMT, all the conduits that we did in chapter 3, I believe, are right in here. Articles refers you to chapter 9, table 1, chapter 9. So shall we go to chapter 9, table 1 and see what they say? Everybody's good with that? Okay. Now go with me, will you please, So please highlight anything that I highlight in your NEC code book. If you want to be professional, guys, you got to have your NEC code book with you and highlight the stuff. This book, if you want to stay in the electrical industry, you're going to live and die by, literally. If you're going to be professional in the electrical industry, your book, your NEC code book that's it. That's how we size and install things. Okay, so let me go take you directly into chapter. Let's go to chapter 9. All these in NEC code book, so I'm going to go directly into chapter 9. Oops, not chapter 8, Chad. Chapter 9, here you go. And I'm going to go into Zoom 75 and minimize this baby. Okay? And get rid of this junk. There you go. So everybody knows why I went to this chapter. Because every article that has a conduit refers me to this chapter. Refers me to this chapter. Okay. So the first, I'm going to highlight a few things, and please, if you have yours, please also highlight them, please. Okay, trying to get rid of that display page. Between, okay, comments, show hide, toolbar. We don't want to show that one here. I'm trying to make it show hide. Okay, rule guide. So explore PDF. We don't want the menu. Toolbar. Navigate. All right. Of course, now it's. All right. So let's go. Let me go minimize this. Make it 100. And okay, I'm going to start with this table. This is the table 1, chapter 9. Can you guys see that? Here's my chapter 9. Here's my table 1 that we will refer to. Very, very important. So let's start one by one. If you have a single conductor or a single cable, single conductor or single what? Cable. So then you cannot fill more than 53% of that conduit. Done. Why do you think they do that? Why don't they want you to fill that conduit 100%? Heat. The issue with filling the conduit, guys, heat. You don't want to put too much heat into the conduit. Why do we care about heat? Because heat will deteriorate the insulation of your conductors. Your insulation of your conductors will deteriorate with heat fast, which will damage the insulation, and in turn, it will end up into a shorter ground fault, and your system will go down. So big deal. So this is if you have one conductor. Now, if you have two conductors or two cables, two conductors or two cables, emphasize the word. You can fill 31%, even less for two conductors or two cables. The reason why less for two conductors, two cables, if you have two conductors, two cables, guys, they will tangle as you pull them through, and they will become hard to pull through. So now that's physical mechanical work. How are you going to pull these two conductors, two cables? Believe it or not, if you have three conductors, easier to pull three conductors or three cables in a conduit than two conductors. Two conductors, they'll tangle. Okay, now, the last one, which is 99% of the time we are in, if you are to fill three conductors or three cables in a conduit, you cannot fill more than 40% of them. Did you guys highlight this? So can I say 90% of the time you're going to be right in here? 90% of the time you're going to be in the 40% fill. Why? Because look at this conduit. At least you need three conductors when you run. At least three conductors, right? You need a hot and a neutral and a ground for most of these conduits. So that's where you have over two conductors. So most of the time when you do a conduit, guys, 99% of the time we have at least three conductors. At least. So that's why 90% of the time you're going to be there. Can everybody highlight that one? Good? Okay. So that's the first thing I would like you guys to highlight. The second thing I would like to go and highlight is a couple of notes here. There are some notes. Can you guys see underneath this table, there's some notes. See information Annex C for maximum. Okay. Then when you go to this table, it will tell you Annex C for the maximum number of conductors or fixture wire if all the same size, cross-sectional area permitted in the size of the... So if all your conductors are the same size and the same insulation, including insulation, then don't worry, don't do any calculation. Where do you need to go? Annex C. Can I guys get you? If all your conductors are the same size, Annex C, what does that mean, Chad? There you go. 1, 2, 3, 4, 5 conductors in a conduit. Each one of these conductors is so 5 number 12 T H H N. I have two options. All of them the same size. Option number 1, you do the calculation that we're going to be doing. Option number 2, which I will always do if they're all the same size, same installation, you go to Annex C and find the conduit, the smallest conduit you can fit these babies. Can you guys highlight this note? So important. That's where it refers you to Annex C. That's why you refer to Annex C. This is note number 2. Note number 2, guys, it talks about applies only to complete conduit or tubing system. Is not intended to apply to sections of conduit of tubing. I'm not going to talk about this one. This is, it will tell you that that's applied to conduits. So I'm not going to emphasize it too much. Complete conduit system, not just little piece of sections. Equivalent ground conductor, if you have an equivalent ground conductor, you have to count it, or bonding conductor, that counts as one conductor. That one conductor. Okay, so let's go to the second, and I'm going to walk you guys through these notes before we. So here's my note. Okay, okay. Now, if you have a conduit, a smaller conduit, can you guys see note number 4? A smaller conduit. A smaller conduit is defined at 24 inches or less. You guys, next project with your friend Chad, we're going to have a panel. Power panel right next to it, a control panel, and we're going to have a nipple between them, little conduit that maps the circuit into the relays in the control panel so we can control them. That's a perfect application for a 24 inches nipple between two conductors. If you have a little conduit, 24 inches or less, from here to here, 24 inches or less, then you can fill 60% of it. Then you can fill 60% of it. That's it. Only, what's the condition? 24 inches or less. You can fill 60% of it. Okay, so that's the most important thing. I want to highlight one more. This will tell you conductors of different, if you have conductors of different sizes, can you guys see the word different sizes? If you have conductors of different sizes, if they're all the same size, Annex C done. Different sizes, would you please go to table 5 or 5A and table 4? So if they're different sizes, you have to go to table 5 to get, we're going to go there in a second, to get the cross-sectional area, and table 4 to add all the cross-sectional area together and find the conduit size. So that's where it tells you if they're different sizes, then you have to use these two tables, which we're in a second. We will be using them in a second. Can I get you guys to understand if all the same tables, Annex C, if all the same conductor size, insulation, Annex C. If they're different sizes in insulation, what do? You're going to go to chapter, table 5, and table 4. Okay? This is very interesting, and I want to highlight this particular number. And I always teach it. Look at 7. 7, it will tell you if your calculation end up. So, Adam, you're doing calculation, and you end up how many conductors can fit in a 3/4 inch EMT. So 3/4 inch EMT, and let's just say, and I know this is not true. Let's just say you end up with 15.8 conductors. 15.8 conductors go to how many? Go to 15 or 16? Based on this rule. 0.8 or larger, you go up. So this becomes what? 16 conductors. Okay, if I end up with a calculation, can you see that? That my calculation end up with 15.7 conductors. This will go down to what? 15. One of the most important ones. Weird, isn't it? Why don't they use 0.5 as going up, rounding up, right? Have you guys emphasized that one when you were in or construction industry? They test you on it on the state all the time. So have you emphasized that one? I don't know, Adam, did you? If it's zero point 0.8, if your calculation end up with 0.8, not 0.5, that's a weird one. 0.8. Go up. Less than 0.8, what do? Go down. The assumption is if you're close to 0.8, you're very close. So they don't want to use 0.5 though. But for all other calculation in any secret book, guys, what do? 0.5, you go up or more. Less than 0.5, what do? So you end up with 15 amps, 0.5. What do? 16. If you end up with 15 amps, 0.4. 15. 15 amps, 0.5, 16. 15 amps, 0.4, 15. Any comments, guys? Any questions? Any comments? Any questions about this little note here? Let me close my email here. Okay, and I can't emphasize, guys, it's very, very important to highlight these ones. These are very, very important to highlight. Okay, so we got that one. So we got, there you go. Okay, for conductors, you have learned multi-conductor cable. If you have a multi-conductor cable, okay, what did we use? For multi-conductor cable, guys, you're going to be using the actual dimension. Same thing. If you have multi-conductor cable right here, you're going to use the cross-sectional area, use the major diameter. I can't emphasize how important this is. Take this. Here's a Romex, right? A Romex. This is 12.2. 12.2 Romex, guys, have the cross-sectional area of it, like have two dimensions. Let's just say this was a 0.25 inches, and this was a 0.5 inch. And I'm just throwing these numbers by any means, right? It's flat, has two dimensions, okay? How are you going to do the calculation? Has two, it's a cable. How are you going to do the dimension? Can you guys see it says the major diameter? Which one is the major diameter? The bigger one. Okay, so in a case like this, for this cable, you're going to use the major diameter, which is this one. Find the area. What's the area of a circle? Pi r squared, right? Pi r squared. That's your area of a circle. What's the diameter of this? The major diameter, the major dimension, major dimension. Not the point means the largest. 0.25 or 0.5? 0.5. This is diameter. So how do you make a radius out of diameter? You cut it by half. So this becomes pi. Oops. 22/7. Pi multiplied by 0.5 divided by 2. Can anybody tell me square? Can anybody tell me why did I divide the 0.5 by 2? This is diameter. I'm giving the D the diameter. Everybody knows the diameter. Radius equal diameter divided by 2, right? From the old math rules. That's how you find the cross-sectional area of a cable. So you can stick it into the conduit. Any comments, guys? Any questions? Any comments? Any questions? What's that? Anybody did the answer? Can you guys do the math for me? Let's find the answer for that one. Grab your calculator. Pi times basically 0.25 times 0.25. Anybody came up with a number? So that would be here. Anybody? So it's going to be a small number. I have 0.19, 0.1963. 4 digits is okay for the calculation. That's what is this? This is a square inch. Square inch. Any comments, any questions, guys? Now here's my question for you. If I have 5 of these cables, well, this is 5 cables, right? What do? You multiply this number, so you take 5, multiply it by 0.1963. There, what's 5 times this number? Why 5? Say there's 5 cables. 5 cables. And let's see what size conduit do I need for them. So it's going to be, give me the actual point. It's very close to 1. 0.9815. Thank you. Any comments, guys? Any questions before we leave this one and go to the actual tables? So that's how you do conduit fill. If it was a cable, that's only if it was a cable. Place of these rules. Okay, now what I would like to go, guys, I would like to go to what happens if all the conductors are the same size? All the conductors are the same size. Let's do me a favor, will you? Go to NX. Let's go to NXC. NXC in NEC code book, please. NXC. When you go to NXC, gentlemen and ladies and gentlemen, you're going to come to this very, very important table. Probably you should start right here. Here's your NXC. Can you guys see NXC, the NEC code book? NXC. When you get it to NXC, you only use NXC, Derek, and Matt if all the conductors are the same size, same insulation. Otherwise, don't even think about it. Okay, look at this. It says NXC, conduits and tubing fill for conductors and fixture wires, and add to yourself also cables here. Also for cables, if you stick a cable in any of these conduits, it applies to it. Okay, there are 12 conduits, 12 tables. Each table is split into 2. I'll make it 24. 12 tables, each one of them is split into 2. I'm going to emphasize the first one. Can you guys see the first one? The first one is for the notoriously famous EMP conduit. The most common conduit, EMP conduit. Okay? The one underneath it, guys, is also, can you see, it's also for EMP conduit. This one for regular conductors. The second one is for compact conductor. Can you just compact conductors. See that one, compact type conductors. So every conduit has 2 tables. One of them is for regular conductors. These are regular. Non-compact. The second one is for compact. Now, what the heck is a compact conductor? A compact conductor is a conductor that, guys, have been made, squished together. All the stranded conductors are squished together to be made smaller in diameter for the same size. For example, if it's compact conductor, here's a 4-aught conductor. If it's compact conductor, the size will be that much. When you put them all together, there's a lot of strands here. This is compact. If it's not compact, the size will be that much. See what I mean? They squeeze these contacts together when they manufacture them. They squeeze them together. They even make them in different shapes. They're round even. They squeeze them together for the same number 4 conductor. The compact ones are smaller in diameter. Who cares? If they're smaller in diameter, you can fit more of them in the same conduit. Now, 90% of the time, you guys are here. So where are you 90% of the time? Non-compact. When were you? And 10% of the time, you will be in this application. If you haven't heard about compact conductor, that's because it's only 10% of the time that you're going to use these. Where would we use them? Retrofit. You have a 4-inch EMT conduit. You outgrow the juice inside the cables inside it. You're lazy enough like Chad, don't want to pull new conduits, bigger conduits. So what do? You pull the conductors out of these conduits and put a bigger conductor, small diameter, which gives you more juice. That's the application for compact conductors. Or if you have a space, limited space, they don't want to give you, you have to only half an inch. Not half an inch. You say you have only 2 inches to put conduit. You can't put 4 inches because of whatever restrictions that you have, structural restrictions on you, mechanical restrictions, architectural restrictions. They don't want to limit you to going through that beam, like for example, going through a beam. The bigger the beam, the more you alter the structural integrity of the building. You screw up the structural integrity of the building when you 6-inch hole in a beam. What's going to happen to the structural integrity of that beam? It goes down the hill. So they want to limit you, say, with 2-inch. That would be a good application. But you still need the same juice. You need juice out of it. Any comments, guys? Any questions? Any comments? Any questions? Okay, so everybody knows. So here's your EMT. You guys will be using most likely in your career PVC schedule. Here's my PVC schedule 80. Can you guys see that? We're going to be using this one. PVC schedule 40. We will be using this one, the PVCs. Rigid is also here. Here's my rigid. Intermediate is here. So flexible metallic conduit, all the conduits, flexible, non-flexible, metallic, non-metallic, that's approved by the code, are here. Any comments, guys? Any questions? Everybody knows where to find the conduit first, the table that you need. 99% of the issue, guys, is to find the right table when you deal with conduit fill. Okay, now we know where to find the tables. Let's go take a snapshot of that. Now let's go, since EMT is my favorite conduit of choice, I'm going to go and to the first table, which is EMT. There you go. So let's go erase and see how does that do for a living. Okay. EMT conduit. Can you guys see where we found? So table C.1, maximum number of conductors in an EMT conduit. I'm going to highlight it this way. I want to emphasize that we are in an EMT conduit. So if they ask you about PVC, Matthew, don't even think about it. This is not the right table. Did you guys hear how important to find the right table first? We know where to find the right table, we just were there. Okay, EMT conduit. Now, suppose that you have a feeder. Suppose that your feeder, let's start with something simple. Suppose you have a number 12 conductor. Suppose the insulation of the conductor was RHH. The insulation is RHH. Okay? And suppose you have 6 conductors, number 12, insulation RHH. What size conduit do I need? All of them, 6 conductors, RHH insulation. What size EMT conduit do I need? So let's come over here. Here's 12. 3 will give you half an inch. No, 6 will give you 3. Is that 3/4? 3/4 of an inch. Can you guys see here 6 here? What's the size? 3/4. My size is 3/4. So what size EMT conduit do I need for 6 conductors? Insulation RHH, all the same size, 3/4 of an inch. So how do you write that one? You're going to go 6 conductors, number 12, AWG, what's the insulation is RHH, will be fit in a 3/4 of an inch EMT. Done. Check. So how hard is that? I bet you my grandma can do that. What do you think, Derek? See how easy that is if they're all the same size? Really not a whole lot. Okay, let's take another example if they're the same size. Take another example. Okay. minimize this. So here's if they're the same size. So suppose I have a feeder. And I need my feeder. Here's my feeder. 400 amp conductors. The number of conductors that's going to be feeding this 400 amp are 4 conductors, number 500 kcm. Okay, I have a feeder, 400 amp, circuit breaker, landing on it, 4 conductors, each one of them is 500 kcm, okay, 500 kcm, and the insulation that I decided to use is RHH, right? Typically, that's what you guys are going to do with shed. You size the conductors. Now, go ahead and size me an EMT conduit that can house these conductors. Okay, so let's go here. So what's the size of the conductor? Here's my size of my conductors. What's the insulation? Here's my insulation. So let's keep going. 0, 0, 0, 1, 2, 2, 3. What is that? Can't see it? That would be 4. And how many do I need? 4, right? I need 4. So this is my 4. How many do I need? 4. Great. What's the insulation? THHL. Great. What's the size? The size is 500. Great. And then you go all the way up, and the size of your conductors, the conduit is 3.5. So this will be 1, 3. Oops. 1, 3.5. 1, 3.5 inch EMT conduit. Any comments, guys? Any questions? That's it. So your conduit, EMT conduit that you need is 1 conduit, 3/4 inch to fit all these conductors. Any comments? Any questions? If all the conductors are the same size. Does it make sense, guys? Yes, no? Okay, let's look at another installation that's more commonly used. So now suppose I'm using THHN, which is 90% of the time we're going to be using THHN. Okay? So if I'm using a THHN, okay, so I have a conduit. This conduit is 3/4 inch conduit, and it's an EMT. And the question would be, how many conductors number 12 THHN can I fit in this baby? How many conductors number THHN can I fit in this baby? Did you guys hear me? How many conductors number THHN can I fit in this baby? Okay, look at the insulation here, Matthew. They're not THHN. Keep going. TW. No, we're looking at the insulation of THHN. Keep going all the way to THHN. Here you go. Now we started with THHN. Can you guys see that? Now we're still in the same table, THHN. Okay, right here. My insulation is THHN, perfect. My size is number 12, perfect. How many conductors can I fit in 3/4 inch? 3/4 inch is actually right here. 3/4 inch, you don't see it at the top. How many conductors? How many conductors? 16 number 12AWGTHHN. So what's the answer here? 16. I can fit 16 conductors, THHN, in 3/4 inch. Any comments, any questions, guys? Any comments, any questions how to use this table? Any comments, any questions? Okay, let's take another example. I have a feeder, 100 amp, residential feeder, and my feeder is 3 conductors, 2 hot and a neutral. Let's use a different. Okay, let's go here. So let's isolate it. Okay, so here's another example. The conductor size is number 1 A W G T H H N. Right? 3 conductors, 2 hot and a neutral. That's landing on a 100 amp circuit breaker, and I need to find the size of an EMT conduit to house them. Okay. All right, so see how easy that is? Let's go to a number. What size? The size, can you guys see the size is number 1? Here's my installation PHHN, perfect. Size number 1, perfect. Go all the way. 1, 1, 1. So that will land me into number 4. And what would that number 4 would give you? Can you guys see what would that number 4? Where at the top of that? Is that an inch, so half, 3/4, an inch and a quarter, an inch and a half? Is that an inch and a half? Are you guys looking at the table? Is that an inch and a half? If you go at the top of the table here, that will be an inch and a half. Can you guys see that? An inch, I'm sorry, an inch and a quarter, inch and an inch and a half, a quarter, an inch and a quarter, right here. Can you guys see that? An inch and a quarter. So that will be, the size here would be then 1 conduit, an inch and a quarter, EMT. Done. 1 conduit, an inch and a quarter EMT to fit all these conductors in it. Any comments, any questions? Is that enough? Does that make sense? Does that make sense, guys? Yes, no? Okay. Let's go take compact conductors. Take a snapshot. And I'm going to go to compact conductors. Now I want you guys to remember. I want you to remember the 1/2 inch, an inch and a quarter. PHHN, we need an inch and a quarter to carry this. Let's go to compact conductors. Okay? Let's go to compact conductors. So for compact conductors, okay? Let's go to compact conductors. The same feeder. I decided to use compact conductors. Keep going down, 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 down. C1, you need to go to C1A. Here you go, C1A. Can you guys see C1A? C1A, it says compact conductors. Now, let's assume these number 1 conductors were compact conductors and go size a conduit. We were an inch and a quarter. See if we can get a smaller conduit. THHN, here you go. An inch and a quarter. Compact conductors, an inch and a quarter. Okay, here you go. So, what was the example that we had? We had 100 amp, 3 conductors, number 1, A, W, G, T, H, H, and compact. I decided to use compact conductors. Okay, so let's go. THHN. Here's my THHN. I need 3 conductors. Number 1, here's my number 1. 3 conductors, here's 4 conductors, and that will give me what? I end up with an inch and a quarter too, same size. It didn't change in this application, but in other application you will get a smaller conduit. This particular example came up with the same conduit, but in other application you will get a different, smaller conduits. Any comments, guys? Any questions? Comments, questions? Everybody knows how to use the tables for compact conductors and the table for regular conductors. Compact and regular. Compact and regular. Okay, so let's take an example about a different conduit, another conduit, guys, and then I'll give you a break. My favorite is PVC. So let's go to PVC conduit. Can somebody tell me what's the page for PVC conduit? So I can type the page right away. What's a page for PVC conduit? 790. PVC schedule 80. 789. Okay, so 789. Let's see where we are here. Mine might be slightly different. Okay, PVC conduit schedule 80. Let's use schedule 80. Maximum number of compact conductor in rigid metal conduit. No, not this one, Chad. Maximum number of conductors or fixture wire in rigid PVC conduit, schedule 80. PVCs, guys, there are two schedules. Schedule 80, big, fat, fluffy, strong for physical protection. Schedule 40 looks exactly the same, but it's thinner, wall, lighter, cheaper. It gives you physical protection, but not severe physical protection. So one of them gives you more physical protection. Cool? All right, so now we're going to use a PVC schedule 80. Let's take this example for PVC schedule 80. I have, for PVC schedule 80, I want to go guess directly into THHN, but I want to remind you, I want you to remember the top here. Let's go to THHW. There you go, THHW. Can you guys see that? THHW, right in here. So, why did I use THHW? PVC conduit, PVC is the conduit of choice when you go underground. Can I put it overhead? Yep. Can I put it right here? Yep. It's conduit of choice when you go underground. So suppose I have a feeder. My feeder is 400 amp. I'm carrying this one with 500 kcm, 3 conductors, 500 kcm, THHW, right? 400 amp feeder, residential, 3 conductors, 2 outer and neutral, service conductors coming to the building with 500 kcm. I could probably gun with 400. Let's use 400 because it's dwellings. We can, for dwelling, we can use 400. Let's use a 400. 400 kcm. Okay? Now, size me a PVC conduit schedule 80 that can carry this baby. No problem. Here's my, we know we're at schedule 80. Here's my THHW. Can you guys see that? Right here. So I'm right in the right column. Then I need 400 kcm. Here's my 400 kcm. How many conductors do I need? I need 4 conductors, so I don't have 3 conductors. I can't go to 2 because that's too small. I have to go to 4. Cross-referencing it, my friends, and you got yourself a 3. So this will be 1 3-inch PVC schedule 80. PVC schedule 80. Any comments, any questions? I can't emphasize, Matthew, you're going to be with Chad from now until the spring. You're going to be using these tables from now until the spring. Done. So these tables, you know it now, you're good to go. You don't know it now, you have 3 more chances to know it with Chad. We're going to be going over it until it gets in here. Cool? Now, shall we use a calculator to find this stuff for you? Starting next semester, this will be a must-have, $63. I'll buy it for all of you guys. You pay me though, $63. And then we use this calculator to do this calculation. Because in the electrical industry, not the electrician though. If you're an electrician, you want to be an electrician, we don't want you to use it much because we want you to pass the test first. When you pass your master and German test, then if you don't have it, as far as I'm concerned, you're not an efficient electrician. So let's go do the same example. The same example with a calculator. Let me show you the calculator they're going to be using right here. Same example. You can use it in any conduit. I don't want you guys to use them while we're designing. This is the electronic version of this calculator. Size picture, let's go to medium. Okay. So I'm going to put it right here, guys. I'm going to go sit myself right. So sit 7. Can you guys see here? 3-phase 75 copper. I'm sitting at 3-phase 75 copper. Actually, probably we are in single phase here. So it doesn't really matter. So I'm going to go sit myself in single phase because we're doing dwelling. Single phase 75 copper. Cool. Now, I'm using it for conduit fill, so it doesn't make a whole lot of difference. 3 conductors, 400 kcm, THHW. THHW. Can you guys see what THHW? Look how you do it. Look at this. Number 1 is, let's go to 400. Here's my 400. Okay. KCM, here's the K, and here's the wire size. So this is 400 copper KCM. How many conductors, Chad, do you want? 3 conductors. Okay, so that's the size. 3 conductors. What size? What type of insulation? THHW. So you put the size first, you put the number of conductors second, and then you hit the conduit size. Here's my conduit size, 2.5 inch. But which conduit? Can you just see the top here? It says what? EMT conduit. What size did we come up with? 3 inch, right? This is EMT conduit. I don't want EMT conduit. I want PVC. So no problem. Click here and here. Here's ENT, not ENT. Here's MC. So it recycle you through all the approved conduits in the code. Let's keep going until we hit the PVC, high is rigid. Here's this, all these conduits. Let's go all the way to see if we can come up with the same size. Rigid, can you guys see the same? Schedule 80. What schedule 80 gave you? 3 inch. Exactly what we came up with. Do you see how handy comes this baby? You might think this calculation is easy to find. Oh, I can't find it in the code. After you come from the break, we're going to do a calculation when the conductors are not the same size. Now, there's a lot of calculation there involved. Any comments, guys? Any questions? How to use? I will walk you through to how to use this calculator, guys, when we get it in 7 weeks, basically. And when you're sitting on your desk, there is no reason for you not to pull that calculator and use it. Any comments? Any questions? Comments, questions? Everybody understand how to use this one? Unfortunately, this calculator does not do compact conductors. So before I let you guys go, I'm going to cross this calculator. I'm going to do the example with compact conductors, will you? Let's do the same thing with compact conductors. Keep all the way to compact conductors. See if we can get what size conduits for compact conductors. Here's A. All right, so here's the compact conductors, schedule 80, perfect. Okay, so let's do the same example with compact conductors. So I need 400 kcm, 400 kcm. Oops, let's move it a little bit slightly up here. Can you guys see that? Slightly up. Here's my compact conductor. Perfect. It's a PVC. It's a schedule 80. Perfect. Here's the table that talks about it. It's a THHW. Yep. And I need how many conductors, guys? 3 conductors. So let's get what size? 400. Perfect. Goes all the way to 3 conductors. What size do I need? What size? Anybody can read it? 2.5. 2.5. So now, instead of 3 inch, if my conductors are to be compact, I need 2.5 inch conduit. The only requirement is compact conductors. Do you guys see that? Everybody can see that? Unfortunately, the calculator that we have, that I showed you, does not do the compact conductors. It does. Why? Because compact are what? 10% of the time. What's 90% of the time? Non-compact. Why? Cheap. Any comments, guys? Any questions? I walked you to summarize before I let you go for 5 minutes. I walked you guys through how to use EMT, compact and non-compact. PVC, compact and non-compact, rigid, flexible, exactly the same. I don't want to spend the whole day talking about it. Can I have thumbs up, Chad? We fully understand how to do compact, non-compact for EMT and PVC and any other conduit. The only difference would be what? Is to go to that particular table. Why don't we have a quick break, guys, 5 minutes, and then when we come back, we're going to do examples. What if the conductors are not the same size or the same installation? Okay, and then we'll wrap up with that one. Thank you. If the conductors are not the same size, what happens if the conductors are not the same size? Can you guys see if the conductors are not the same size? It will tell you right in here. You need to go. This is the situation that 90% of the time you're going to find yourself in. Oh, I don't know, maybe 80% of the time. You're going to find yourself with conductor not the same size. So you have to go to check table 5 or 5A and table 4. Here's the magic about it. First, you need to find the cross-sectional area of all the conductors. Second, you have to add them. You can't find the cross-sectional area from these two tables. So that will give you the cross-sectional area. And then you add them up. You add all the cross-sectional area. And then after you add them up, you come to table 4 to find yourself the conduit that can get you that total cross-sectional area or more. That's the magic about it. We need to do a little bit more math. Because the conductors are not the same size. Okay, let's go ahead and do it. So I'm going to take an example here. There you go. So everybody knows when the conductors are not the same size. Before we go ahead, guys, I'm going to go give you a tour of table number 4. Here's table number 4 that keep referring to. Dimensions. Dimensions, table number 4, very, very important, guys. Table number 4 gets you the fill for all the approved conduits in any secret book. All the approved flexible metallic conduits. Oh, first, metallic, non-metallic, flexible, or non-flexible. All the conduit in the code, flexible, non-flexible, metallic, or non-metallic, are in Chapter 8 conduit fill. So let's go to the 90% of the time that you're going to be using, which is EMT. So the first thing is the article talks about EMT. Here's a conduit of choice, which is 90% of the time we're going to be using EMT. Look how to use this table. The way we use this table, number 1, there are 90% of the time you're going to be right in here. Can I add 90% of the time? Where are you going to be? Over 2 conductors. So 3 conductors or more, you're defaulting to 40% fill. That's from table 1. We just talked about that one. Okay, so let's start with half an inch. For half an inch, so that's 90% time. If you have 2 conductors, then you're going to be in 31 fill. If you have 1 conductor, 53 fill. If you have a nipple, which is 24 inches or less, you're going to be landing under where? 60-degree column. 60-degree column. Take this example. Let's take an example. Easier. Suppose I have an inch. I like an inch. Here's an inch. An inch. If you use an inch conduit, empty conduit, if you use it as a nipple, 24 inches or less, 18 inches, how much can I fill out of that inch? Can anybody read this number for me? 0.864 square inches. That's how much I can fill out of this inch. 0.864 square inch. So when I add the cross-section area of all my conductors, I shall not exceed 0.864 for this particular conduit. If I do, then what do I need to do? Go to the next size. Okay? That's if it's a nipple. If we're using it, guys, as where am I? I'm sorry. My apology. It should be the nipple. This is all the cross-section area. We don't use it a lot. For nipples, it's right in here. So 0.519. For nipples, it's going to be 0.519. The cross-sectional area cannot be more than 0.419. Everybody can see the millimeter, squared millimeters and squared inches. We use the squared inches, right? In the US, if you're doing a job in Brazil or anywhere else where they use the millimeters, you can use this one for metric system. Everybody understand? Except you're going to shift to the left 1 column. Okay. Now the same concept, if I decided to use it, guys, as one conductor or 1 cable, multi-conductor cable, 1 conductor. Suppose that 1 conductor, how much can I fill out of this baby? 0.458. Can you see it's less? A little bit less than a nipple. Keep going. Now what happens if I want to use that conductor as 2 cables? How much can I fill out of the 2 cables? 0.268. 0.268. It's much less. 2 cables are much less than 1 cable. Do you guys remember what we said? Why 2 cables much less than 1 cable? They tangle. As you pull them, they tangle if it's only 2. If it's 3, easy to pull. 1, easy to pull. 2, tangle. Right? Okay. So these are, all these scenarios, guys, only 10% of the time. 90% of the time, you're going to be right in here. So 90% of the time, you're going to be filling what? Right in here. So 3 conductors or more, that will get you 0.346. That's how much you can fill out of this conduit. Any comments, any questions? See how easy to use that table? Like 90% of the time you're going to be here. The rest, only if it applies to them. Do you have one cable, one conductor? No. Then you go to here. Do you have two cables or conductors? No. You go to here. Do you have a nipple, 24 inches or less? No. You default to here. So this is your default. Unless you have a one conductor, a nipple, 24 inches or less, or two conductors, or two cables. Ladies and gentlemen, this table, table 4, is for every single approved flexible or non-flexible metallic or non-metallic conduit in the code. They have a table like this. Can I have a thumbs up, Chad? We know how to read the table first. Okay, let's go to, so I'm going to go capture this. I'm going to go directly, I'm going to keep going down in a second here. Okay, so I'm going to go get rid of this stuff. I can't emphasize, guys, you should have your NEC code book and highlight when you have it. All these are very, very important because we repeat itself. The second conduit is ENT. This is your ear, nose, and throat doctor. That's, I call it the ear, nose, and throat doctor, the ENT. Here's a flexible metallic conduit, the same way. Here's IMC, same way. Liquid, flexible, non-metallic conduit, all the conduits. I want to go all the way to PVC. Can you guys see every rigid is here? PVC Schedule 8 is my favorite. So I want to go to PVC Schedule 8. I'm going to do the same example for PVC Schedule 8. 1 inch. If the 1 inch is, if it's a nipple, how much can I fill out of this 1 inch? I don't know if you, that will be this amount. If it's one conductor, that will be, right, this amount. If it's two conductors, that will be this amount. If it's three conductor, which is 90% of the time they're going to be using, it will be this amount. Did you do them right? If it was a 6-inch rigid, you can see the column that you're going to be looking at right here. Any comments, any questions? Everybody knows how to use the 60, 53, 31, or 40% fill. Why do we use which one of them? Which 90% of the time we're where? Right here. Only 10% if it applies. Do I have a nipple? 24 inches or less? No. Go here. Do I have one conductor, one cable? No. Go here. Do you have two conductors or cable? No. Go here. Does that make sense? Can I get you guys to understand that one? Perfect. Let's go to, this is table 4. That's a table 4. That's across, you find the cross-section area of the conduit and how much of this area can I fill? It's not enough that you have the conduit. How much of this cross-section area you can fill? I don't know if you guys can see it. Here's the area for an inch. The internal area for an inch is 0.688. But this is the total area. But how much of this area can I fill? It depends. How many conductors are you bringing to that conduit? Can't fill it all. Okay? Questions before I move to table? This is table 4. Table 4, table 5 is like saying the Twin Cities when it comes to conduit fill. Somebody say the Twin Cities and you say Bloomington, Richfield, right? Or Minneapolis, St. Paul. It really is. When it comes to conduit fill, table 4, table 5, table 4, table 5. That's exactly Twin Cities. I call them the twin tables. They go side by side. So we got into the table 4. Now let's go see what the heck is table. So table 4 can give you the cross-section area that you can allow to fill. Table 5 will get you the cross-section area of the conductor. How much cross-section area this conductor is going to have? Okay? So let's take this one and go to table 4, and then we'll take an example. How about that? Okay, so let's take that one. So now that we know how much you can fill out of each conduit and what are the scenarios for filling them, okay? Let's go all the way to table number 5. Table number 5, 5, 5, 5, 5, all the way. Here we go. Table number 5. Table number 5, guys, is so interesting. Here's table number 5. The way we'll be using table number 5, it's the dimension for insulated, can I emphasize the word insulated conductors fixture, by the way, when you see a fixture wire, that's the wire that they use inside the fixtures. We don't use it for wiring, but we use it between fixtures and inside the fixture. So you can ignore that one. Insulated wires. Now, let's just, because I want to stay here, let's use an RHHW right here, okay? RHW-2, RHW-2. I have a 4/0. What's the cross-sectional area for a 4/0? Okay, this one will give you the diameter. No, we don't want that in inches and millimeters. This will give you the area. That's what I want, the area. Oh, don't go to the millimeters because we are not in Europe. We're in the US. So where are you going to go? To the inches. And you, my friends, your default is going to be right this column all the time. And for that particular conductor, the cross-section area of 4/0 is not just 4/0, 4/0 with an insulation RHW-2. The insulation will decide how big the cross-section area or not, right? Because you can have thick insulation or thin insulation. The cross-section area will be different depending on the insulation on the conductor. Okay, so my cross-section area for one conductor is 4754. Done. Take this. Now suppose I have, for this example, I have 4 conductors, number 4/0 AWG, insulation RHW-2, and I need to find an EMT conduit that can fit that baby. Cool? They're all the same size. That's easy. Okay, so we can go, for this one, we can easily, guys, go to where? To NXC. But we're not going to do NXC, so how do you do that? You take you're going to take, let's use a different color here. How many conductors do I have? 4. What's the cross-section area of each conductor? Is 0.4754. Who's going to be my A student who's going to do the math for me? So 4 times 0.4754. I need 2 people to agree on that. 1.9 even?
1.9016.
0.16. That's when you need to get at least 4 digits after the decimal. Did you approximate this one?
No.
Okay, what was that digit after the 6?
There was no digit after.
Oh, good, perfect. Any second? You second it? Okay. So that's the 4 conductors, all the 4 together, they're going to occupy 1.9016. That's when you add them all together. Cool? Can I have a check, Chad? Good. Up to this point. Now let's go find an EMT conduit that can handle these babies. All right, so I'm going to take this one. Let me take a snapshot at this first, and then we'll take it into the EMT conduit. Same scenario. You're going to see now. Okay, now I'm going to go take it all the way to the EMT conduit. Keep going up, 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 up to the first conduit in 4. Here you go. Okay, here you go. So I'm going to go just for the clarity here. So not this one here. Here you go, Chad. I'm going to go for the clarity. Just erase this one here and erase this one here. Okay. And here's my example. Can you see my example? Now, what you're looking for, gentlemen and ladies, what you're looking for is this number. Okay, how many, do I have 4 conductors? Right, so where am I default? Right here. Can I go to here, here, or here? No, why? I don't have a nipple. They didn't say 24 inches or less. I don't have 1 conductor, I have more. I don't have 2 conductors, I have 4. So I'm defaulting here. Then, next, the cross-section area is 1.901. So you come over here and start reading. I need a 1. Is there any 1 here? Start right here. 1.342, small. Right? 1.342 is small. So the next size is 2.343. Am I right? Everybody can see that? Because 1.342 is less than 1.9016. So I have to go to the next standard. Then, when you're done here, then you're going to cross-referencing yourself all the way, and this will translate into what size conduit? 2.5. So what size conduit do I need for these babies? 2.5. 0.5-inch EMT conduit. Done. Any comments, any questions, guys, how to use this table? That's if all the conductors are the same size. You could have used NXC or these two tables. I have option. Now let's take an example where you don't have an option. You have to use this. Shall we? Okay, so let me take a snapshot. Everybody can see how that goes. Everybody knows why I went to the next standard, why I didn't use 1. And by the way, what I'm doing here is I'm taking snapshot and it will be PDF on the network for you. So if you don't have your code with you, you can look at them and highlight them because they're similar to what you have in the code, the same actually. Okay, but I can't emphasize when I teach this one for the apprentices, guys, and for the people who sitting for their exam, they get confused. Everybody knows why I jumped from here to here because 1.312 is less than 1.9016. You have to go to the next standard. Why didn't I go here, 5.901? What's wrong with going to this? This is bigger than that. What's wrong with that? Anybody? Overkilling. When you size a conduit, what do you size? The minimum. What do we size conduit? Minimum, not maximum. Maximum, I can custom design myself an EMT conduit that's 5-inch diameter. You know, we always look for what? Minimum. Why minimum? Cost in labor and material. And overkilling. If you need if you need 1/2 inch, why would you put 3-inch? Now there is a situation, guys, when we go higher than the minimum, future expansion, right? There's a lot of other reasons why, but you have to know at least the minimum. Then as an engineer, Derek, my friend, and Matthew, your minimum is going to be 2.5 inch. You know what a lot of engineers would say? I'm going to go to next standard higher. I'm going to go and sit, instead of, we're sitting at 2.5, I'm going to make it 3-inch, bigger. But at least we know how to size it minimum based on NDC code book. Cool. All right, so now let's go take an example, guys. I'm going to take an example. Here, touch on conductors in a conduit that's different sizes. So let's go use the following. A good example. Let's go to table number 4 again. And can you guys go to THHN all the way until you find THHN in the column? Can you guys see where THHN right here? Everybody can see THHN conductor right here? Okay, THHN. Which page is that? This is page 718. 718, will ya? 718. Come over here. All right, so here's the scenario. We hired my friend Adam to design a system. Adam decided to do the following. Here's Adam's design. And if you guys are mad at him, don't be mad at me. He has a box. And Adam decided to bring the following conductors in the box. He decided to bring 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 conductors. So these will be 9 conductors, number 12 A W G T H H N in one conduit. Then these 9 conductors were actually feeding lights. Okay, or feeding lights and so forth. Then he decided to also spice it up and add a couple of other conductors in it. So I'm going to have 1, 2, 3, 4, 5, 6. And 6 more conductors. This will be 6, number 10, A. Oops, I don't want to draw that one because I need this area. So this one was 6 conductors, number 10, A, W, G, T, H, H, N. Okay? Now I have 9 conductors, number 12, T, H, H, N, and 6 conductors, number 10. Now you're going to kiss goodbye, you see NXC. You can't use NXC now. Done. No NXC. Can't use it. Okay, so how are we going to do that? Let's go. First, we're going to go to table number 5. Here's my THHN. Luckily, all of them are THHN. If one of them is PF cable, you're going to go down here. All of our THHN, so insulation is good. Then, the next, we're going to go to number 12. The first is number 12. The cross-section area for number 12, gentlemen and ladies, as this number. Then I'm going to go to number 10, right underneath that. The cross-section area of number 10 is this number. Cool? Everybody can see that? Right? Now, what are we going to do? I'm going to go, how many of these do I have? Multiply this, the number, how many 12 do we have? Multiply this by 9. Multiply this, the number 10 multiplied by what? 6. And add them up. Add them up. Find the cross-section area of each size. Multiply it by how many conductors you have for that particular size. Add them up. So who's going to be my favorite? A student. So we're going to take 9 multiplied by 0.0133 and then add it to 6 multiplied by 0.0211 with one step in your calculator. Shall we? I need 2 people to do it and come up with the same answer, will you? So I have point times 9 plus anybody came up with an answer? What is that? 0.24. All of it together added? I came up with 0.8448. Did you add them all up? 9 times the first number plus 6 times the second number? Can somebody check both our works? Anybody? Calculators? Karen? I need to verify 2 people come with the same answer. So take 9 multiplied by 0.0133 and then add to it 6 times 0.0211. I came up with 0.8448. I don't have my scientific calculator on me. I'm using it on that one, which I don't trust that much. Did you guys come up with the same answer? Please. What did you come up with? 2? Okay, then my calculator, I don't have my scientific calculator. I could be wrong too. I don't have my, what did you come up with? 0.2463. Then you guys are right. Again, I don't have my scientific calculator. This must have, okay, 0.2463. Do I have 2 gentlemen agree on one number? Then that's it. 2.2463. This seems it doesn't have brackets on it to do the calculation. Okay, so you came up with the same answer, 0.2463. Any comments, guys, about that one? Multiply them. Take the 9, multiply by this number, 6, multiply by this number, add them up. Add them up. I don't know why my calculator came up with this. Okay. Any comments, guys? Questions about that? Now we're done. We came up with this answer, right? So we added these 2 together. Add them up, multiply them. So 0.246. Let's go size an EMT conduit. Which conduit do you guys want to use? Let's go first size an EMT conduit. Okay, and then we can size another conduit for it. Cool. Let's size an EMT conduit. So take all this junk that we did all the way to the EMT conduit. Okay, let's take it all the way to my EMT conduit. Here you go. Here's my EMT conduit. It's hard to see now because of all the junk that we have over there. So my EMT conduit, guys, I need, what size do I have? I have 0.2463. 0.2. It's hard to see here. I'm going to move it up a little bit so I can see it. Okay. So I'm looking at, I need to look at 0.2463 right in here. 0.213, 0.3. So what do you guys think of this one here? Why? Everybody knows why I went to here. So my point, my 0.346, right, is more than 0.24. So cross-referencing that boy, that will get you an incher. Are we in EMP first? We should be table. Oh, where we need the table. Which table we need? Dimensional percentage. Okay, this is not table 1. I need to keep going here, Chad. No, that's right. Table 4. Yep. Here you go. So I need to point 0.246. Okay, 0.21 point. Okay, so that will give me an inch. Right? Is that an inch? Give you an inch. Let's use the calculator and see if we're right or wrong. Shall we? Before I go to the calculator, any questions? So that's if the conduit is EMT. We're going to do the same example if the conduit is PVC. Because the calculation is exactly the same. You just go to different table. Okay, so let me go fire my calculator, guys, and see if we can get the same example here. If we did the math right. Okay, minimize it. Picture size, minimum. Okay, so I'm going to put it right in here. We came up with an inch. So I'm just going to go put what size? 1 inch EMT. That's what we came up with. Okay, how to use this calculator? So set this one to 75. It doesn't matter. It's 3-phase or single phase. For conduit fill, it really doesn't matter. Okay, look how we do it. First, make sure you clean. Can you guys see? I'm clicking on this one. What I'm gonna input this information, the 12. So first you start with 1, 2. That's a 12. Here's a wire size. So that will give you 12 copper. Yep, copper 12. How many of them? 9. So then you hit 9. And what type of insulation? THHN. 9 THHN and hit enter again. That's the cross-sectional area of all your 9 conductor CHHN. Check, done. Now we're going to go to the second size. What's the second size? The second size, guys, was number 10. So I have number 10, wire size. How many of them do I have? 6. So here's my 6. And what type of insulation? THHN, hit again. So if you hit it again, it will give you how many conductors and what's the total is. Can you guess? This is the total. Does this match with what you come up with? Identical. So that will prove that Chad is wrong, right? Does it match exactly what you guys come up with? Same calculation. See how easy that is? And then now the conduit. What type of conduit do I need? EMT conduit. Hit the conduit. And here's 1 inch EMT conduit. Isn't that what we came up with? 1 inch EMT conduit. I don't know if I get it wrong. That one. Here's my EMT conduit. Here's my EMT conduit. Any comments, guys? Any questions? See how easy that is? Talk about easy. When they do a code update for the journeymen and masters, they said, if you don't have one of these in your truck, you don't exist, man. And you do a lot of sizing. So easy. Couple of steps, but you have to use it right, though. You have to start by putting the size of the conductors first, then how many of them? Hit enter. Size of the conductors again, how many of them? Hit the size, and then go to the conduit. Okay? Any comments, any questions, guys? Now, since I have the calculator, I'm gonna go do the same thing for EMT, for PVC. See what size, what if I was using PVC? Because same calculation. So for PVC, I'm cheating him looking at the back so I can go, I have to hit 9. To change this one into PVC, what you do is you hit 9 and set and here. So same thing, 9 for PVC, schedule 80. Can you guys see switched? It's still 1 inch. Okay. Did you guys hear me? EMT 1 inch, PVC 1 inch. They don't have to be the same. They do not have to be the same. Now I'm going to go, based on the calculator and based on what I did, I'm going to go to the table of the PVC and see, would I come up with an inch like the calculator said? Shall we? Okay. So I'm going to minimize my calc here, put it right in here. And I want you guys, please, to go all the way down to PVC conduit, will you? PVC, 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 IMC, PVC. Okay, PVC schedule 80. Here you go, Chad. PVC schedule 80. Okay, PVC schedule 80. For PVC schedule 80, guys, I need, what size do I'm looking for? 2.2463. Same thing, 0.2463, 0.24. Okay, so that will get me, is that a 3/4? What did I, well, I'm looking for our original PVC schedule 80. Isn't that schedule 80? That's an interesting, right? So I came up with a smaller size. Did we do the math right? So I came up with 0.2463, 0.2427, so that must be here, right? And then that will get me a 3/4. That'll give me a 3/4 of an inch. Give me a 3/4 of an inch. Right? Based on the table, 3/4 of an inch. I'm going to use the calculator one more time, right? Am I missing anything, guys? Everybody, 0.2463, 0.27, so that's the next standard that we need, right? You don't go to the edge. Let me see if we get the calculator right in here. Let me erase this one here and put it one more time, shall we? 9, okay. So we're set at PVC schedule 80. Are we in PVC, by the way? Is this a PVC schedule 80 up? Perfect. Let's do it, guys, one more time, will ya? Here you go. So I need number 12. Here's my 12 wire size, right? How many of number 12 do I have? I have 9 of them. I have 9. What insulation do I have? THHN. Click on it. Here you go. How many? Then you go to the 10 wire size. How many of the 10 do I have? I have 6 of them. 6. And THHN. Click here. There you go. The same size, right? These two numbers are the same. Then I'm going to go conduit size. 1 inch. Interesting. Give you a size up a little bit. Interesting. Are we missing anything here? I don't see anything. Not missing anything. Copper. Okay, so we're gonna go. You're gonna go basically based on NEC code book. It gives you a little bit size up. That's interesting. We hit the same insulation, right?
No, you were on the wrong one. Should have been
Where was I?
It kind of messes you up because the first row gets you off, and you're only counting the first 3 numbers, but it should be 1 down. It should have been 1 inch on the table.
So here, that's what I thought. Yeah, you're right.
That first line kind of messes you up.
Yep. That's what I thought. Okay, thank you. Yeah, right here. That's what I thought. Where the heck? Here you go. Here's my number. So you start going all the way up. Yep. Thank you. I was about to call them. So you're right. It's an inch. So they are right. We're right. Everybody's happy, huh? There you go. 1 inch. Thank you. It because of that line messes you up a little bit. Thank you. 1 inch. So everybody's happy with the calculator. You approved it. Any comments, guys? Any questions? Any comments? Any questions? What I'm going to do, I'm going to take one more example with flex. Let's take an example with flex, guys, and then I believe, and I want you guys to, so here's my calculator. Snapshot of that baby. All right, so let's minimize this. So here's what I would like to do, guys. I'm going to go flex. I want to go flex it. Let's go to THHW, will you? THHW. Is THHW. Can you guys see that THHW here? Okay. I have the following scenario. I have a piece of equipment here. Where are we going to put the piece of equipment so we don't get confused? Here's a piece of equipment, and I'm flexing it. This is my flex, going to a disconnect. Okay, flex. This is flexible metallic conduit. How about liquid tight? Liquid tight. Let's use liquid tight flexible metallic conduit. Liquid tight flexible metallic conduit. Shall we? because we're outside. So let's use a liquid tight flexible metallic conduit. Liquid tight flexible metallic conduit. Liquid tight flexible metallic conduit. This is a piece of equipment. This piece of equipment, guys, I'm bringing to it the following. I'm going to be bringing to it 3 conductors, number 4-aught, A, W, G, T, H, H, W, and I'm also bringing to the same conduit 1 conductor, number 3-aught, same insulation, and 1 conductor, number 1. Okay? Everybody's with me, guys? I'm bringing 1 conductor number 1, 1 conductor 3-aught, and 3 conductors 4-aught. Typically for 3-phase system, guys, we'll have 3 conductors for the 3-phase, 1 conductor for the neutral, 1 for the ground. So I'm bringing 3 conductors for the 3-phase, 1 for the neutral, 1 for the ground. Okay, so I would like you guys to do the math, please, with me. So let's start with the top. I have 3. Let's start with the smallest conductor. Here's my insulation. My insulation is THW for all of them. I'm going to start with number 1. The cross-sectional area for number 1 is this amount. Multiply this one by 1. Cool? Because how many of them do I have? 1. Let's go to the second one. The second one is 3-aught. Here's my 3-aught. How many of them do I have? I have only 1. Multiply this by 1. And the last one, guys, is going to be my 4-aught. Here's my 4-aught. How many of them do I have? I have 3. Multiply this by 3 and add them up. Can somebody do the math for me and give me the answer, please? So here's my example. I have a flexible, liquid tight flexible metallic conduit that's feeding a machine. 3-phase and a neutral and a ground. Anybody? Guys, when you do the calculation, I will give you credit for participation. So just FYI, you get credit for participation. What did you come up with?
1.6172.
I need somebody else to.
What's the green one?
The green one
3117.
is 0.3117. What did you come up with there?
1.6172.
1.6172. I need somebody else to verify that number, please, before we go ahead and move on. 1.6172. Okay, perfect. So 2 gentlemen, or a gentleman and lady, will never disagree on something wrong, right? That's what we say, verify each other's calculation. I would like you guys to, when we do calc, I would like you to grab your calculator and be with me. Cool? So that's part of your participation. That's why you get 10 out of 10 in participation or less. Okay, so we have 1.172. Now, cool? Everybody's cool with that one? Based on verification, let's go capture it. Now I'm going to go find, now what type of conduit I'm using? I'm using liquid tight flexible metallic conduit. So let's go all the way up to table 4, and I want you guys to help me here find, here's my PVC rigid. I'm going to find rigid again, liquid tight flexible metallic conduit. Liquid tight flexible. Can you guys see that? Isn't that what I want? Everybody can see that? Liquid tight flexible metallic conduit. Can I have thumbs up, Chad? That's a conduit, because I have a tendency of throwing up. Okay. So here's my cable, liquid tight flexible metallic conduit. It's not, is it a nipple? Nope. Are they one conductor or 1 cable or 2 conductors or 2 cables? No. So where am I? I'm right in here, gentlemen. Right in here. Okay. So let's go look at I'm looking for 1.617. 1.617. So it's 1.6. There's no, so everybody agrees that this is the number? Am I looking at it? Please verify here. 1.953 is the next standard after 1.617. You're looking at a number larger than 1.6172. Okay? Now, Help me here, go to the right column here. Am I here? Thank you. 2.5. Everybody can see that? Am I in the right column here? Yep, 2.5. So what size of this baby do I need then? 2.5-inch liquid tight flexible metallic conduit. Liquid tight flexible metallic conduit. Or LFMC. LF, there's no T in the name, so let's just use what you call it. Liquid tight flexible metallic conduit. That's the name that they use for it. So let's just use the same name. So be consistent here. Liquid tight flexible metallic conduit. Shall we go use a calculator to verify that? See if we come up with the same answer. Cool? When you work in the field, guys, it's all about speed. You know, I can do it by math, you know, or if I have my calculator handy, I plug in a couple of numbers and off it goes. Okay, so let's go take my calc. I'm going to go erase this one on my calc here. I'm going to go change my calculator to the liquid. By the way, on the back of the calculator, it tells you how to change it. So I'm looking at cheating here, looking at my calculator. To get a flex, liquid tight, flexible metallic conduit is 7. So I have to change this one by hit 7, set, and conduit size. Liquid tight, flexible metallic conduit. Remember, this was for the size before, so we haven't put the numbers yet. So go clean, make sure clean, but I'm setting my calculator to 7, set, conduit. I'm setting my calculator to liquid tight, flexible metallic conduit. Cool? Nothing in the calculator yet. I cleared the memory. All right, so let's go put the conductors. You guys have to help me. Oh, they're here. So I want to start with the 4 conductors, 4 aught. Here's how you put 4 aught, guys. 1, 2, 3, 4. These are 4 zeros. 4 aught. Wire size. What type of insulation? What is it? THH W? Okay. So how many of them first? How many of them do I have of this size? 3. So hit 3 and THHW and hit enter. Okay, that's a cross-sectional area for the 3 of them. There's right underneath it, THHW. Yeah, both of them in the same column. Okay, and then see that. Then I'm going to go to the next one is the 3 aught. So here's my 1, 2, 3 wire size. How many of them do I have? 1. Same insulation. Hit and hit it again. Here's the total for these 2 sizes together. One more size is left. Number 1. Here's 1. Here's wire size. How many of the 1 do I have? 1. 1 of 1. 1. THHW hit. Okay. All right. So what did we come up with total? Did we come up with this total? 1.6172. 1.6172. Not what we came up with. That's a total for all of them together. Cool. The size of my conduit is 2 inches. Let's go hit the conduit size and see if we can come up with 2.5. There you go, gentlemen. 2.5. If you know how to use a calculator, see how fast that is? Instead of, oh yeah, did they click on the wrong number when they're calculating it? I always say when I teach this calculator, I said, in order to use this calculator, Matthew, professionally, you have to spend 4 hours monkeying around with it, plus listening to your friend Chad. Otherwise, don't even mess with it. Because you click on the wrong number, you screw up. Like everything else in life, garbage in, garbage out. But the same thing could be said when you were transferring these numbers, right? You click on the wrong number, screw up. That's why you do it twice when you do it in a real project. I usually clear it, do it twice, I come up with the same answer, then I check. Just because human error. Any comments, any questions? Any comments, guys, any questions about the conduit fill? So now we have done conduit fill, verified it with the calculator. The last thing I want to do about the conduit fill, any comments, Matthew? You guys have never heard of it, you and Dirk. Is this good information to get you up and running with it when you come to the conduit fill? The last thing, guys, I want to do is, in the last 5 minutes left here. Now, what happened? All these sizes that I came up with for conductors of fully insulated. So let's go all the way. Let me erase this jump here. So table 5 was for insulated conductors. Now what happens if I have a non-insulated? Can you guys look at table 5? Can anybody read what it says here? Table 5, dimensions of insulated conductors and fixture wires. Now what happens if the conductors are not insulated? There are 3 types of conductor you're going to encounter in the electrical industry in terms of insulation. One is fully insulated, that's THHN, RHHW. Insulated, the insulation is right here. Approved as insulation for voltages. It will protect you from being shocked by the voltage. That's what an insulation is. That's what you guys have been using. That's 90% of the time that we're going to use. Now, the second 2 types of conductors are bare conductors. They put them outside on poles. Utilities use them all the time. No insulation in them. Or if you put them in a conduit, no insulation in them, use them for equipment ground conductor because they don't carry current, right? Ground conductor, no insulation whatsoever, bare. That's the second type. And the third type is in between the bare and the insulated. They call it covered. Covered, what they do is they put some cover, not insulation, some non-conductive material cover on it to protect the conductor. But it's not rated to insulate from voltage. So you're not supposed to grab into it if it's a hot conductor. So where would you use this one? They use it if for hot conductors, overhead conductors, they cover them. So if a branch hits that conductor, it doesn't short immediately. It protects it from. But it's not supposed to for you and I to go grab into that conductor because that's not rated to insulate the voltage. It's rated to protect the conductor. So if you have a covered or bare conductors, this table will do you no good to find the cross-section area of that. Did you guys hear me? So you're going to go to a different table. The table that you're going to use is table 8. How do I know that? That's all from the NEC code book, right? So you're going to go all the way to table 8. Okay, here's table 8. Table 8, guys, we're going to use table 8 for a lot of things. So suppose I have number 8. Let's go number 10. Number 10, bare or covered. Number 10, bare or covered. Here's number 10. Oops, Chad, there are 2 number 10s. Which one am I going to use? There are 2 number 10. Is it solid? If it's solid, this one for solid. The second one underneath it, guys, is for what? Stranded. 1 for solid, 1 for stranded. If it says 1, it will be solid. If it says 2, it will be stranded. Can you guys see that? 1 solid, 2 stranded. So, all right. So, what's the cross-sectional area of this baby? The cross-sectional area of this baby area is here. Here's inches. The first one is going to be 0.008, and the second one, gentlemen and ladies, it's going to be what? 0.011. Can you guys see that? There are 2 cross-section area for the same type of conductor. If it's insulated, it has 1. If it's solid, it has another. After, can you guys see after size 8, from here down, can you guys see they're all insulated? I mean stranded. They're all stranded. Number 6 and larger, they're all stranded. Any comments, any questions, guys, how to find the cross-section area of conductor if it's bare or covered? Bare or covered? Can I have thumbs up, Chad? Yes, we can find it if it's bare or covered. Okay, so that's easy. So when it's bare and covered, you're going to ask yourself, is it stranded or solid? If it's solid, Matt, you're going to be using the one that has quantity. Can you guys see the quantity that says 1? If it's stranded, you're going to use the 7. That's it. The last thing, and I promise this time is the last. How about stranded? How about compact conductors? What happened if the conductors were compact, fully insulated but compact? So that's for covered conductors. We got that one. Let's go to compact conductors. Here's my compact. Can you guys see 5A right in there? This is for compact copper or aluminum conductors, compact conductors. Everybody understand what compact conductors are? Specially made, squeezed together to give you smaller diameter for the same size. Take this. Can you guys see that they start at number 8 because they don't use them for solid. These are all for stranded conductors. So you're not going to find a compact conductor number 12. Okay, 4-aught. Here's my 4-aught. Let's say the insulation was THHN. Here's my insulation THHN. Here's the area. Here's the inches, and if it's THHN, and here's the area right in here. So 0.2780, right? It's a 0.2780. That's the cross-section area of 4-aught if it's compact conductor. Then the calculation stays the same. If you have 4 of them, you multiply this number by 4. You go to table number 4 to find the conductors. Any comments, any questions? Summarize. For conduit fill, guys, before I let you go, if all the conductors are the same size, we have to go to Annex, not we have to, you can go to Annex C, done. If the conductors are different sizes, then you're going to go to table 5 to find the cross-sectional area if the conductors are regular. Table 5A if they're compact. Table 8 if the conductors are cover or bare. When you add the cross-sectional area of all the conductors in a conduit, then you go to table 4. Table 4 will give you, based on the cross-sectional area and the fill, will give you the size of the conduit that you need for this system. Any comments, any questions? Matthew, Derek, is this enough for you guys to get into the conduit fill business? Is this a good review for you guys to get into the conduit fill business? Karen? Okay. So that's the whole conduit fill business. So we call it the conduit fill business. Now, when you guys start sizing for Chad, on your plans, when we have the riser, I want to see when you see 4 conductors, 400 kcm, I need to see a conduit right next to it, PVC, underground PVC, overhead EFD, done. All sized. Cool? That's all I have for you guys. Any comments, any questions? After Labor Day? A lot? For 2 hours, not a big deal though. All right. I'll let you guys. So the rest of you guys are going to be working on the layout of the power, and I'll be helping you as we go. Thank you. Take a snapshot.